Recursion. In this example, we're going to take a number. Here's just an example. Excuse me, an integer 1, 2, 3, 4, and display it vertically down like this. So we have to take the individual digits and display them. So the base case, or the stopping case, is going to be when the number reaches just one digit, because then we can just display it. So if the number is less than 10, that's going to be our base case. Our general case, or the recursive call, is we're going to call the function with the number divided by 10. So think about 1, 2, 3, 4 divided by 10 is 123. And then we're going to write the number mod 10. 123, 1, 2, 3, 4 mod 10 is 4. So we're going to recursively call the function with this, and then we're going to write the 4. And then the number the next time through is just going to be 123. So we'll recursively call it with the 1, 2, and we'll write the 3, and etc., etc. So here's what the function looks like. Right vertical, we pass our number in. If it's less than 10, we just display the number. Otherwise, we call right vertical with the number divided by 10, and we output the number mod 10. So let's kind of follow this through. All right, so here's our function call, right vertical, 1, 2, 3, 4, right? It's a void function. So first we call it with 1, 2, 3, 4. If the number is less than 10, well, it's not. So we're going to call right vertical with, 1, 2, 3, 4 divided by 10, which is 123. And then we're going to see out the number mod 10, which is 4. Now, just to show you what happens here, okay, right vertical, okay, so right vertical gets called. So with 1, 2, 3, it jumps out to here. So we haven't output the 4 yet at all. Okay. So next we're in this function call with just 1, 2, 3. So if the number is less than 10, no, it's not. So we're going to call right vertical with 1, 2, 3 divided by 10, right? 123 divided by 10 is 12. And then 123, we're going to see out 123 mod 10, which is 3. Now remember, the see out has not happened yet, but we're going to go ahead and we're going to call right vertical with 12. Okay, so now if the number is less than 10, no, it's not. We're going to call right vertical with 12 divided by 10 is 1. Now remember, this is all integer division. And then 12 mod 10 we're going to output, which is 12 mod 10 is 2. So again, we call right vertical, this time with 1. And now we meet our base case. If number is less than 10, which it is, then we're just going to see out the number, which we're just going to see out 1. So at this point, it's actually going to finally output something, right? Up here, oops, it's going to output our 1. And then this function is going to end. And when this function ends, right, it comes back here. And then it's going to output the 2. Right? And now when this function ends, right here, it's going to come right back to here, and then it's going to output the 3. And then when this function ends, right at the end of this function, it's going to come right back to here, and it's going to output the 4. Right? And then this function ends. Now, I didn't do a very good job of this because this should look like this. There's an end-al at the end of each of these, so it should display 1, 2, 3, 4, or vertically. Okay, sorry about that. All right. Um, Now this is not contained tail recursion, as you can see, and if we tried to implement this with a regular type of repetition like a while loop or a do while loop or a for loop, it would be harder to do that. There's not going to be a lot of function calls, because even if the number gets bigger, let's say it's a, in a 4-digit number, right? We've got 1, 2, the original function call is 1, 2, 3, 4, 5. But if it was a 5-digit number, we would have 6. If it was a 6-digit number, we would have 7, right? So, I mean, as the number gets bigger, the number of function calls doesn't get that much bigger. So that kind of shows you that this is a really good example of something that you could solve recursively with a much, a recursive solution would be much more efficient. And that's what you try and look at with recursion. There's a lot of algorithms and data structures which are kind of recursive in nature. So you can come up with much better, faster, more elegant solutions when using recursion.